Ladies and gentlemen, welcome to the Introduction to Programming Part 2. In this session, I introduce you to one of the most powerful programming concepts, the loops. Loops allow you automatically repeating certain tasks in an efficient and intelligent way. In C#, looping can be done basically in 4 different ways, with so-called while loops, do-while loops, for loops, and for each loops. We look into each of them in the following. Therefore, let's start Rhino and Grasshopper and open our introduction file, Programming Basic Concepts. To start, please go to the example number 2, loops, and right-click on the component and enable it, this command. Then it turns into green if you have selected it, and it already sends some outputs to our panel. Double-click on the component to open the script window, and I will zoom in into the first part. So we will start with the while loop. You see, before I look into the while loop, we declare a variable, an integer variable called number, which we initially set to 0. In the next part, we start with our while loop, and we tell our computer that he shall repeat something until this condition is fulfilled, which means until the number variable is smaller than 5. Or it shall repeat something as long as the variable number is smaller than 5. What we repeat is written in these brackets, parentheses. We do something very simple. We print our number variable to our panel. With the print command, we send something to the out parameter, which we see here, and this is drawn in the panel. The number is an integer variable, as we've declared it here. In order to print it, we need to convert it to a string, because only strings can be printed. Therefore, usually all kind of variables and many objects have, not the variables, the base structures and classes have the property toString, which means they convert themselves to a string, so to say. Therefore, we write number dot toString, and afterwards 2 parentheses that are empty, means we don't need to send any variables to this method. This line of code will print the number variable. And in the next line, we increase the number variable by 1. Which means when we run through our first iteration of the loop, we start with number 0, and in the second line of our loop, we increase the number by 1. And if the loop arrives at its end, this bracket, this parenthesis, it starts again from this one. You see what is inside part of a code inside the parenthesis. If you click in the beginning or in the end of a parenthesis, click here, then it marks black the end of the part, so the end of the open and closed brackets that belongs together. So here this parenthesis belongs to this one. Means the code inside goes from here to there, and then it starts again in a loop, in a while loop. So imagine if you run through this loop once, then number is set 0 plus 1 is 1, means number is, the number variable is 1, is still smaller than 5, so we continue once again. We print the number again, and we increase it once again by 1. Now our number variable is 2, still smaller than 5. Go through it now it's 3, once again it's 4, until it's 5. 5 is not smaller than 5 anymore. This means our while loop ends here. After it ends, it jumps to its end, so to the parenthesis that's closing the loop, and the code continues to the end, but all of this code is deactivated, so we end at our run script method, means our code finishes. If we run it, we see what we've already seen in the beginning. We print numbers from 0, 1, 2, 3, 4, which is what I've explained to you, the iterative increasement of our number variable. In the last session, I've already shown you that you can write this in the short form if you set it, or if you use the syntax. Number plus equals 1 gives you the same result. So once again, we print this. If we, for example, increase the end condition to 15 and run it again, then our code runs from 0 to 14. Usually in programming, the indexes, because the first row of this output is the index of our output numbers, so the index starts with 0. Because if we start the number variable with a 5 and say, okay, now it's 5, and we loop through this while loop until it's as long as it's smaller than 15, and we run it again, you see it starts still with the index 0, but the first value is 5, then the index 1, 6. We will come back to these indexes later if we look into arrays or lists. So far, we are finished with the while loop. Now we can uncomment and deactivate this part of the code and look into the next loop construct. That's the do while loop. It's basically very similar than the pure while loop, with the difference that the do while loop first runs through our loop, and after it's executed the first time, so we printed our number, then it asks if it shall repeat what it has done so far or before. So it asks if it should repeat this part that we have written into our parentheses, starting from do, and the while says, if this condition is true, please go back to the do, the beginning of the do, and iterate once again. Here again we start from 5, means the first time 5 will be printed, independent of our condition at the end, and then it will ask if the condition is true and repeat it. So what happens? We start from 5. And this time we increase the counting variable, our number variable, by the value 2. So here we start from 5, then in the next iteration it's 7, in the next one 9, 11, 13, until it's 50. If we would start with, let's say, 25, which is already bigger than 15, so for the while loop, this would mean it would not execute what is inside the loop. The do loop runs it runs once until it asks if the condition is true. So if we do this, then we print first the number, increase it by 2, and then ask if the condition is fulfilled. It's not fulfilled, so it's not repeated, and the code continues from here. That's the difference between a while and the do while loop. The do while loop is doing something in before it asks if it shall be repeated. The while loop first asks if a condition is true and the content of the loop should be executed. These kind of loops, they were relatively straightforward to understand because we already know about about the declaration of variables. Here our counting variables, which is called number. That's what we have known from the introduction to variables. Now we look into a little bit more complicated construction of a loop, the for loop. So here we have the keyword for, and it have in this round parenthesis three parts, three commands, three elements of the loop. The first one is once again a kind of a counting variable, the I, which tells us where we want to start. Usually we start, for example, with I equals to 0. The second one is the condition, which was in the while loop, what was written here, while number smaller than 15, for example. Here we say repeat the loop until I is smaller than 10, for example. And I equals to I plus 1 means we increase our counting variable by 1. This is the I, and before we called it number. That's the same. You could also call this one number equals 0, numbers bigger than 10, and so on. But in this case, usually we use only one character, so the I. And here we say I will be increased by 1 after each iteration. So in the end of the for loop, I is increased by 1. And now we start if I is smaller than 10. We repeat the for loop as long as I is, that's the correct form. We repeat the for loop as long as I is smaller than 10. Now, again, in the for loop, we print only our counting variable, which is I. I converts itself to a string and is printed. If we run it, you see we print from 0 to 9. That's because we repeated 10 times. Starting from 0, it's prints 0, then it increases the counting variable I by 1, what's written here. Then I is 1, still smaller than 10, so the condition is true. It's repeated once again, I is 2, 2 still smaller than 10, once again, and so on and so on. Basically, it's the same as a while loop, but we put in this part of our loop command all the variables and conditions that are distributed in this form of a loop. So here we needed to write the counting variable at the top of it, then the while command, and then we need to increase it somewhere else in the code. If you imagine you have a longer part, a longer, more complex loop, then this can be written somewhere. So this form is easier to keep an overview over it. But you can do the same what we've done with the other loop, so we can also write the other form, which it increases our counting variable. We can also increase it by a bigger value, by 3 for example. Then we start with 0 and increase it by 3 in each iteration. We can start with a different value, 147, and as it was written in the beginning, we could also set it to a 9, and we can call, or we can change our condition that it shall repeat the loop until I is bigger than 0. And now we need to decrease our counting value, counting variable, for example, by 2. And now you see what happens is we start with 9 because we set it to 9 in the beginning. Then we print the variable, the counting variable. Then we decrease the counting variable by 2, means 7. 7 is still bigger than 0. Do it once again. Decrease it by 2, means 5, and so on and so on. So you can play around with this part of the for loop in a similar way as we've done it with the while loops. Okay. Now the last part of our loops is the for each loop. This is used basically to iterate through a list or an array or some kind of storage for a set of numbers or variables. In this case, we use string variables. And you can iterate through them automatically without taking care about the numbers or how many elements you stored in this list and what kind of order they have and so on. So you can iterate just automatically through a collection of variables. Therefore, here we introduce a list. That's kind of an extension of a variable. Means we use a string variable, but in this variable we cannot store only one value, but more than one, a list of variables, as many as we want. And therefore we declare the variable called list. It's a type of list, or it's a list of data type string. So with this kind of bracket, you introduce the type which is allowed to be stored in the list. And then we say we want to make a new list of the data type string, which is empty in the beginning. To add an element to a list, we don't use the equal. Now we use the keyword add. So we use the list. What's the name of our list? And we say we add an element, and in our case we add a string. So that's our first string. So therefore it's written in a quotation mark. You could also say that's the first string. Also number is converted into a string if you put it into the quotation marks. Then the second string is added and the third string is added. It's just an example that we add 3 elements to a list. And now with the for each keyword, we can iterate through this list automatically. Therefore we need this part of the code. This is the condition. The loop is repeated as long as we have elements in our list, and we somehow take out the element in each iteration, starting from index 0, then second, third, and as many as we have, and store it in each iteration into this locally declared variable called name. So we say this is a variable, and it has the value that corresponds in the beginning to the value 0 from the list. So let's make it more clear. If we execute our loop, you see we print it again, and in the first position, the first index of our list, we've stored first string, which is printed here. In this case, we don't need to convert the variable name with the to string because it is already a string, and it's printed to our panel. And you see what happens. So for each loop, it starts with the first entry. Then after it ends the loop, it starts once again with taking the second item out of the list, and it's printing the second item, the second string. And then it once again starts the loop with taking the third element out of the list and print it. After all elements are taken from the list and in our example printed, the for each loop ends, and we continue with the code, which is finished so far. To make it clear that you can replace most of the list, most of the for constructions with each others. We have here added another example which uses a for loop that is doing the same as the for each loop. So we still use our list variable, and we say we want to repeat something starting with the local variable I, our counting variable, which is set to 0. And I want to repeat my for loop as long as the elements in my list are bigger than my I counting variable. So with the count, I can access the number of elements in my list. So this will repeat me the number 3, because I have 1, 2, 3 elements in my list. And I increase I by 1, which is what you see here, another way to write that the counting variable shall be increased by 1. Means I plus plus, or any kind of integer value. If you write plus plus behind it, then it's increased by 1. So just an abbreviation. Instead of writing what we've written here, I plus equals 1, we can write I plus plus. And once again, we print what's in our list. And in this case, we need an address, which element we want to print. And we say we use therefore these kind of brackets that gives us the element at this position. So in the beginning of the loop, it takes element 0, then it repeats it, I is 1, so it takes out the first element of our list. Let's run the code. What we see, that's written by the for each loop. Then we print here this separator, and then we are doing exactly the same with a different syntax. I've shown you this just to explain once again that you can very often do things in a different way in scripting and coding, but achieving the same result. And it's up to your taste, up to your skills, to your knowledge, which style you use. Usually there is no right or wrong. Ideally, you use the form that's simpler, means better readable, better understandable, especially for yourself. But in the end, you are free to choose which way you use. In this case, for example, for a loop, you can use a while loop, a do-while loop, a for loop. Only the for each loop that's applicable only for collections like lists or others, which we will learn later how they work. With this, we are at the end of this session. Thank you for listening.